Informal Algorithm by Arnold Torres. Introduction. Informal algorithm is a set of rules that precisely define a sequence of operation in all computer programs. An example to determine the maximum common divisor of two integers can be seen on a Euclidean algorithm. Bowles and Jeffrey offer in a formal meaning of the word in the following quotum. No human being can write fast enough or long enough or small enough, smaller and smaller without the limit. You'd be trying to write on molecules, on atoms, on electrons. To list all members of an enumerably infinity sex by writing out their names one after another in some notation. The concept of algorithm is also used to define the notion of dedicability. That notion is central for explaining how formal systems come in being, starting from a small set of actions and rules. In logic, the time that an algorithm requires to complete cannot be measured. Is a It is no apparently related with our customary physical dimension from such uncertainties that characterize ongoing work, esteem the availability of a definition of algorithm that suits both concrete in some sense and abstract use of them. Now, description. A step-by-step process that describes how solved a problem or complete a task, which always gave a result. There were more precise that informal instruction and did not require any knowledge or intelligence to follow. However, they were not precise enough for a computer to follow. These were often expressed using pseudocode, which matched a programming languages fairly closely, but left out detail that could easily be added later by a programmer, and didn't specify the kind of command that can be used. For example, go to the kitchen, pick up a glass, turn on the cat, put the glasses under running water, and remove it once it is almost full. Turn off the tap and take the glass back to the person who gave the instruction. A human call could follow this instruction easily, but a computer could not figure out exactly what to do. Informal algorithms, first algorithm cost, searching algorithms, and sorting algorithms. Algorithm cost. When computer scientists compare algorithms, they often talk about the cost of an algorithm. The cost of an algorithm was interpreted in several different ways, but it was always related to how well an algorithm performs based on the size of its input, the amount of time a program which performed the algorithm took to complete may seem like the simplest cause we could took at, but this could be affected by a lot of different things, like the speed of the computer was used or programming languages the program had been writing in. This means that if the time the program took to complete was used to measure the cost of an algorithm, it was important to use the same program on the same computer or another computer with the same speed for testing the algorithm with different number of inputs. Searching algorithms. Searching through collection of data was something computers have to do all the time. It happened every time you type it in a search on Google or when you type it out in a file name to search for on your computer. Computers deal with such huge amount of data, and we needed fast algorithms to help us with information quickly. You might have noticed that the number of on a monster and pets in the game were in a random order, which meant that found the pet was basically luck. You might have found it on your first try, or if you were less lucky, you might have to look inside almost all the presents before you found. This might not seem like such a bad thing since you had enough left to tuck under all the boxes, but imagine if there had been 1,000 boxes or worse, 1 billion. It would have taken for far too long to look through all the boxes, and the pet might have never been found. Sorting algorithm. Sorting was another very important area of algorithm. Computer had to sort large amount of data into order based on some attribute of that data, such as sorting lists of file by their name or site, or email by the date they were received, or a customer list according to people's name. Most of the time, this was done to make searching easier. For example, you might have a large amount of data and each piece of data could be someone's name and their phone number. If you wanted to search for someone by name, help it to first have the data sorted alphabetically according to everyone's name. But if you then wanted to search for a phone number, it would be more useful to have a data sorted according to the people's phone numbers. Sorting's algorithm has three sub-algorithms. Scale interactive. Throughout this section, you could use the sorting interactive to text out the algorithms we talked about. When you weren't using it, make sure you took note of comparison at the bottom of the screen. Each time you compare two boxes, the algorithm is making one comparison, so the total number of comparisons you have to make each with each algorithm is the cost of algorithm for eight boxes. Selection sort. One of the most intuitive ways to sort a group of boxes into order from lights, lights of highest was to start by first finding the light or heaviest box and placing that to the inside. This algorithm was called selection sort because each time you looked through the list, you weren't selecting the next lightest box and putting into the correct position. If you went back to the algorithm racing interactive, you may now be able to watch the selection sortlist and understand what it is doing at each step. Whicher insertion and selection sort may seem like a logical way to sort things into order, but they both took far too many comparisons when they weren't used for a large amount of data. Remember, computers often have to search through huge amount of data, so even they used a good searching algorithm like binary search to look through their data. If they use a bus sorting algorithm to first sort of the data into the order, then finding anything will take for too long. This algorithm was a little more complicated, but it's very powerful. To do this algorithm with a sorting interactive, start by randomly choosing a box and placing it on the scale. Insertion sort. This is algorithm worked by removing each box from the original group of boxes and inserting it into this correct position in a new sorted list, like selection sort. It was very intuitive and people often performed it when they weren't sorting objects themselves like cards in the hands. Discussion. Why the informal algorithms are the important in our life and in our daily life? Commonsensical math and physics is enough for most people to get around, like crossing the law taking shorter time than going around it. Algorithms to come in handy for some tasks that some people might face daily. You can use in sort of activities in your job and any personal situation. For instance, administrative work, scheduling or prioritizing, divide and conquer, and driving. However, most of the time the inputs themselves aren't specified very well, and the factor involved in the problem may not be fully known. This requires the insight and experience of human beings to judge, approximate, and create some model of it before algorithms knowledge will be held. Knowledge of algorithms can be generally helpful for people to solve several types of real-life problems, although with some approximations sometimes as a quick solution which can be modified upon. Thank you.